All right, when we look at a sector of a sector is basically a portion of a circle that is surrounded by two radii, and it has an arc as well. So you can see some examples of it. It says, in design and engineering and in pizza, as the slice of a circular pizza is almost always a sector. To me, it kind of looks like Pac-Man's mouth. So if you were to look at this image in number one, from B around to A, and the major arc would make the Pac-Man, and then this sector here would be Pac-Man's mouth. So that's another way to look at it. So in example one, we are looking at a circle with radius 12, and that's marked for us. Central angle 60 is also marked for us. So if you have that information without a diagram, you're just going to want to draw a couple of radii with the central angle in there and try to make it as proportional as you can so that it looks as close to accurate as it can be. And so we know that we have this is called a minor sector, and that formed by those two radii. And the reason why it includes the word minor is because it's bound by a minor arc. So we have a minor sector, we have a major sector. So to determine the circumference and the area of circle O, and leave our answer in terms of pi, all we need to do is take that circumference formula and insert the radius. So I'd have circumference equals 24 pi. If I want to go to the nearest hundredth as an approximation, I can do that. For the circle area formula, I'm just going to insert the radius one more time. 144 pi would be in terms of pi, and then 452.39 if I'm using my calculator. So just a review of area and circumference there, and both of those formulas are going to be needed to calculate the sector. So what portion of the circle's area and circumference are shaded? Well, what we're looking at there is 60 degrees out of a total of 360. So you can reduce that fraction and say that it's 1/6 of the circle. How we know that is because every circle has 360 degrees in the center. So if I'm looking at a shaded section of 60 degrees, that would be the portion of the circle that we're looking at. So determine the length of arc AB and the area of sector AOB in terms of pi into the nearest hundredth. Well, the length of an arc is related to the circumference. So if the whole circumference was 24 pi, and now I'm looking at 1/6 of the circle, I can calculate that just by doing 1/6 times 24 pi. That gives me a total of 4 pi, which would equate to about 12.57. And we can do the same thing with area. If I want to know the area of the sector, I'm doing 1/6 times the total area. That gives me 24 pi, or 75.4. All right, so anytime we need to know an arc length or a sector area, we just want to use the entire circle and then establish a fraction to multiply by. All right, exercise 2. Try this one on your own. Look at the angle in the center and try to apply the formula that or the process that we just did on the problem before. All right, so we have a sector radius 20 and central angle 110. So what I want to do first is think about what the area would be of the full circle, and then I'm going to multiply by a fraction that indicates how much of the circle is shaded. So 110 degrees out of 360, that fraction of the circle will be applied to the total area. It comes out to about 384 feet. All right, let's move forward. Exercise 3. So as long as you can use a proportion, you can really do anything with arc lengths and know that it's going to be directly proportional to the central angle. So in this text, and you'll again be asked to draw these yourself sometimes, but the garden is in the shape of a sector such that its straight sides are 50, so that's the two radii, and the central angle is 132. If we want to surround by fencing, how many feet are needed? Well, we know we need 100 feet for the two straight segments. All we need is the arc length, and then we'll have it. So if I take the perimeter of this thing is going to be the circumference of the circle times the fraction of the circle that I'm looking at plus the two straight segments. Those are the components of this perimeter. So it comes out to about 215. So if we want to know the perimeter of a sector, it's the same as doing an arc length. You just have to make sure you add on the two radii. All right, sector of a circle in exercise 4, radius is 5, area is 20. Is the central angle of this sector acute or obtuse? All right, well, to picture this, what I want to do is just draw a sector with radius 5. So I don't know the angle, so I'm going to just draw a random sector with an unknown angle, and the radius is 5. So if I want to know the area of that sector, the area would be pi times 5 squared times theta over 360. And this is the fraction I would use to establish that. So all I want to do now is put 20 in for the area, and then I can solve it from there. Okay, so if I put a 20 in on the left side, I can then multiply pi times 5 squared, divide by 360, and divide that over to the 20. Or I can multiply by 360 and divide by the pi over 5, the pi times 5 squared. Either way, theta comes out to be about 91.67 degrees. So is that acute or obtuse? Well, it's going to be obtuse because it's a little bit more than 90. All right, so again, if you know the area, set it equal to the area formula, put in your radius and solve for theta. All right, and finally, exercise 5, a horse attached to an 8-foot-long rope can rotate through a distance of 28 feet. So we know the arc length that it can travel, this circular piece here. What angle can the horse walk about? So we want to know what this angle is in this spot. Well, this 28 feet this time represents a portion of circumference. So to establish that, I need to think about 2 pi r instead of pi r squared. I know the radius is 8. I don't know the angle, but I do know the perimeter is 28. So we have all of that information. And then I can just solve for theta. And when I solve for theta, I get 201 degrees. Okay, so the whole key to this lesson is this theta over 360. So we already know a circumference formula, we already know an area formula. It's just to apply those formulas to this fraction, or apply the fraction to those formulas, and then we can establish an arc length or a sector area.